Alright, so in this video I'm going to be talking about the unit circle and how to evaluate trig functions at different angles. So let's talk about the unit circle quickly and kind of recap what the unit circle is. The unit circle is just a circle centered at the origin that has a radius of length 1. And we look specifically at some of our benchmark angles in either degrees or radians. And using special right triangles, we're going to identify a lot of key points around our unit circle. So I'm going to model how we find the point for one of the special right triangles, and then I'm going to use my completed unit circle to kind of show some examples of then how to use it to evaluate some trig functions at certain angles. So let's take a look. Let's say I've got my unit circle and I've got an angle of 30 degrees. So let me draw an angle of 30 degrees here, roughly something like this, okay? If I have an angle of 30 degrees and I drop down right here to make a right angle, then this is a right triangle in my unit circle. My hypotenuse is a length of 1 because it's just the radius of my circle. And if I want to find this coordinate right here, my x and my y coordinate, then I would just need to find the bottom of my triangle, which would be my x coordinate, and this side of my triangle, which would be my y coordinate. So let's think about what we know about a 30, 60, 90 triangle. I'm going to draw a separate one over here. Anytime I have a triangle like this that's a special right triangle, 30, 60, 90, I have a relationship between the sides. I know that if this side right here across from 30 is x, some number, then the hypotenuse will be double that. It's going to be 2x. And this side across from 60 degrees is going to be root 3 times whatever x is. Okay, so let's use what we know about our unit circle. In our unit circle, the hypotenuse of this triangle here with a 30-degree angle is 1. So I could set this 2x equal to 1 and use that to then solve for x and find these other sides. So if 1 equals 2x, then I could divide by 2 on both sides, and that means x equals 1/2. So this side right here would be 1/2, and then this side would be root 3 times x, and if x is 1/2, excuse me, then we'd have root 3 times 1/2, or root 3 over 2. So this side would be equal to root 3 over 2. So let me label this on my unit circle. This side down at the bottom across from my 60-degree angle up top would be root 3 over 2, and this side across from 30 degrees would be 1/2. So my coordinate would be an x value of root 3 over 2, and it would be a y value of 1/2. Okay, so the same thing is true for a 45-degree angle, a 60-degree angle. As you go and use some of these benchmark angles, you can use the special right triangle for that angle, and you can identify the x and y coordinate of the point touching the outside of the circle. When you finish, you end up with something that looks like this. So you have 30 degrees, or you could write it, of course, in radians, pi over 6, 45, pi over 4, 60, pi over 3, and the coordinates. And then we can use that first quadrant to figure out all of your other quadrants. For example, in the second quadrant, if I have 150 degrees right here, then my reference angle is a 30-degree angle. So I have this same right triangle that I just looked at, but reflected over here. And so I'm going to end up with the same 1/2 and the same root 3 over 2, except it's going to be a negative root 3 over 2 because I'm going backwards root 3 over 2. So that's where this point comes from right here. So I can follow all those patterns all the way around the circle and end up with all of these coordinates for all of these different angles here. Now, something helpful to think about also is, remember that we proved the other day in class that for the unit circle, since the radius is 1 and our hypotenuse is 1, x is always going to be equal to cosine of our angle, and y is always going to be equal to sine of our angle. So if I ask you to evaluate a particular angle here, a trigonometric function at a particular angle, then we can find cosine by just looking at our x coordinate. We can find sine by looking at our y coordinate. And then remember, tangent is always opposite over adjacent. So think about your y over your x. So I'll write that one off to the side too, y over x. And we have all of the reciprocal functions, cosecant, secant, and cotangent, which is just going to be the reciprocal of these three. Okay, so let's look at using all these tools that we just talked about to actually evaluate some specific trig functions right here. So let's say I ask you to find sine of 5 pi over 6. Now at any point if you're on a calculator section, you could just use your calculator to evaluate this, but make sure that you know whether you're in degrees or radians. This one your calculator would need to be in degrees. This one your calculator would need to be in radians. A lot of times though, I'm also going to expect you to do this without a calculator by using your unit circle. So if I have sine of 5 pi over 6, I just need to think about where that angle would be. If I am thinking of pieces that are pi over 6, like 30 degrees, those pieces look like this. So if I have 5 pi over 6, that'd be 1, 2, 3, 4, 5. 5 pi over 6 is an angle right here. Okay, and I can think about that point right there. It's going to come from the same as the 30-degree angle we just did, but in the second quadrant it would be negative root 3 over 2 1/2. And let's check. Yep, that's what I have right here for 5 pi over 6. I got negative root 3 over 2 1/2. I just had to think about it for a second. And I want sine, which like we just talked about is our opposite over our hypotenuse, or our y, because it would be y over our hypotenuse is 1. So I'm thinking about what is my y value at 5 pi over 6, and I check that out, and my y value is 1/2. So when you do this on your calculator, you should get 1/2 or 0.5. Okay, let's try another one. Cosine of 240, if I think about this angle, 240 degrees would be down in the third quadrant right here. And that reference angle right here would be like a 60-degree angle, because I would go 180 plus another 60 degrees to get to 240. So if I think about that point right here, that point would be coming from a 30, 60, 90 triangle, but the opposite of before, because we're dealing with the 60-degree angle. So I have 1/2 and root 3 over 2, and both of them are negative because we're in the third quadrant. Since I'm looking for cosine, I'm looking for x. Let me just check one more time. Yep, for 240, there they are. Our x is negative 1/2. So we'd be looking for negative 1/2 for that one. That should be what you get when you plug it in your calculator. Okay, next one, cosine of 2 pi over 3. 2 pi over 3. Now pi over 3 is equal to 60 degrees, so our pieces would look something like this. 2 pi over 3 would be 2 of these, so it would look something like that. So the reference angle right here is pi over 3, or 60 degrees. So our point is the same as this one we just did, but my x is negative and my y would be positive. And let's check. 2 pi over 3, here it is. Yep, negative 1/2 root 3 over 2. And I want cosine, so I want x, so I want negative 1/2 again. Okay. Tangent of pi over 4. A couple more examples for you. Tangent of pi over 4. Pi over 4 is going to be in the first quadrant, equal to 45 degrees like this. So this is a 45, 45, 90 triangle. And I remember that my coordinates for that end up being root 2 over 2, root 2 over 2. And I want tangent, so I want y over x. So I want root 2 over 2 divided by root 2 over 2. Now anytime I take a number and I divide it by myself, I just get 1. So this would simplify to 1. So tangent of pi over 4 is equal to 1. All right.